Ever had your renders come out looking not quite like you expected? Backgrounds gone missing, HDRIs not being applied as they should. Are you using IRay Server for your renders? Either locally, or using a cloud GPU service like Boost For Daz? If so, I may have an answer for you. And some good news. You see, I had this happen to me. And as it turns out, your renders are perfectly fine. They just need a slight aftertouch, you'll see. All shall be revealed. But first, intro. So the problem I ran into is this. I had this scene with a massive load of geometry in it, a very high-resolution HDRI as a background, and my local machine was like, "Ow, no mate, please don't." Perfect candidate for cloud rendering. As I was going to generate an HDRI from my scene, I needed a set of renders on different exposure levels. Sounds like just the right type of job for a beefy GPU in the cloud. So off to Boost For Daz I went. And sure enough, an appropriately spec'd server was able to plow through my renders like a hot knife through butter, and I was free to continue doing other work on my local machine while I waited. A few hours passed, and was able to download my results. I had been monitoring the progress while it was rendering out, and the previews looked beautiful. All was well. Or so I thought. As I downloaded the results and opened up the renders to take a look at the beauty of my creation, I was met with this. Let's just say, this was not exactly the result I was expecting. And this was quite a surprise to me. The previews didn't look anything like this. So what was wrong? I immediately went to the support team for Boost For Daz. You know, your server is broken, type of thing. Fortunately, I was met with a member of their excellent support team, and together we were able to work out what was actually going on. He pointed me to a couple of support articles on how to work with IRay Server. But more importantly, he was able to offer some insights that led me in the right direction. Turns out, there is a link on Boost For Daz that explains something about PNG alpha channels, and how Daz by default tells IRay Server to render images using the alpha channel. The article tells you to queue up your renders and then go change this default to switch off the alpha channel. And sure enough, while that works, I am much too forgetful a person to remember that. Plus, I already had a bunch of very heavy renders that were already done. Did I have to do them all over again? Fortunately, the answer is no. I know this now, but I feel I must point this out. When I worked through the problem with the Boost For Daz support team, they very kindly allowed me the free use of their A40 servers to redo my renders. Kudos for excellent customer service. So how do we fix this? I'll show you two techniques. One will be using Photoshop, and one will be using the excellent and free ImageMagick software. I'll post a link to ImageMagick below. First, the Photoshop route. Right-click your seemingly broken render and select Open with Adobe Photoshop. Your image opens up, and here you will very clearly see the alpha channel and the transparency of your image. Let me be clear on this. If I'm an idiot when it comes to using Daz, this is nothing compared to how I feel when in Photoshop. There are likely smarter ways to achieve the result I am now going to produce. Feel free to share your insights in the comments below. Anyway, what you want to do is fix the opacity of your transparency layer. If a non-opaque transparency layer confuses the heck out of you, that makes two of us. I'll discuss some rationale for this in the text section later on. Anyway, select Layer, Layer Mask, and then, from Transparency. Photoshop responds in kind by creating a new layer mask based off the transparency information in your image. You see it here. Double-clicking it brings up the properties of the layer mask. Notice how the density is at 100%. As it turns out, this density is really the opacity of the transparency layer. Very zen. The transparency layer is 100% opaque. Or to put it differently, your transparency layer in your image is hiding the background. Don't you just love working in computing? Knowing this, the fix is easy. Either move the density slider down to expose the true background you were expecting in your image. Alternatively, just enter 0% into the box. And behold, The beautiful night sky, by Orestes Graphics, now shows over my cityscape. Success. Now let's take a look at an alternative way of doing this. There are no doubt dozens of ways this could be achieved, I just wanted to show off two. One using commercial software, and a free option. For this, you are going to need to download and install ImageMagick. I've put a link in the description below. Make sure you select to install the legacy tools when installing. Once installed, navigate to your Downloads folder, or to wherever you have a file that you want to fix the alpha channel. Now we're going to use a little bit of command line magic. In the navigator above, click and type in PowerShell. If you're as old school as I am, you might also type in CMD. Both will work fine for what we're about to do. Once you've safely arrived in PowerShell, you're just a simple command away from fixing the alpha problem. Type in the following. Convert. Name of your image file. -alpha. Off. Name of your image file again. Alternatively, you can give your image a new file name if you prefer to keep your original intact. And that's it. ImageMagick will get to work on your file and sort out your alpha channel for you. Success. And now, a warning. I did a little bit of digging to try and make sense of how an opaque transparency layer could make any kind of sense. For some of you, the following information is going to make a lot of sense. For others, no sense at all. It's fine, you're done with the video now, consider this more of an epilogue. As for myself, some of this makes sense. And yet, not as much as I'd like to. If I get some of the details wrong, feel free to share in the comments below. Right. So I went and looked up the specification for the PNG format. Dear Lord, let's fix up this design a bit. Get rid of the ugly background. Fix the font size a bit. There we go. PNG defines the alpha channel as an opacity map, rather than how we, or I, at least, normally think of it, namely as a transparency map. Simplified, in pixels, a value of 0% would mean a fully transparent pixel, and a value of 100% would mean fully opaque. Values in between specify the degree of opacity of the given pixel. If we take this back to what we saw in Photoshop, 100% opacity is the same as 100% density. And by reducing the density, we introduce transparency. Don't say I didn't warn you. Looking into the rationale behind this, a bit of sense starts surfacing. PNG uses what is called non-premultiplied alpha, which is basically another way of saying the alpha information is stored separately in the file from the actual image bitmap itself. To understand why, we need to understand a little bit about how pixels and colors are stored. I'm not going to get too deep into this, as this could easily be a very long topic. But for simplicity's sake, let's assume that a value of 0 represents black, and a value of 1 represents white. Now let's also assume that the opacity for the given pixel is 50%. Calculating the resulting pixel color would be as simple as multiplying the two. For the color white, the calculation would be 1 times 0.5, 50%, resulting in a pixel color of 0.5. A grayish type of color. One could then store this information in the image, and be done with it. The alpha channel information would have served its purpose. But here's the catch. What happens then to fully transparent pixels? The opacity would be 0% and any calculation you put through this would end up with the result 0. Which is also black. If PNG was to pre-multiply the alpha channel information like this, information would be lost. It would not be possible to distinguish between a white pixel, value 1, with 0% opacity, and a black pixel. They would both end up with the color 0. And while this may seem obvious to some, this is where we find our root cause. And this is why, manipulating the transparency mask in our PNG file and setting the density/opacity to 0% reveals the background image information that appears lost in our renders. I honestly don't know if any of this helped, or I just confused matters even more. Fortunately, you don't really need to know. I've already shown you how to work around the problem and get the beautiful renders you deserve. And that's all I have for you today. I hope you learned something. If you did, this is YouTube, you know how this works. Feel free to like, subscribe, and share this video to whomever it might concern. It really helps me out. Have a wonderful day.